Hi class. In this video we'll continue our chapter 2 presentation and look at math operations or arithmetic operations. When computers were first invented, one of the main things that people wanted them to be able to do was math. Nobody really likes it. Now when we're working with variables, sometimes we want to use a variable to save the result of a math operation. So if we had a calculator, we might do some sort of formula on our calculator and the answer would display on the screen. We can think of a variable as kind of a place to save that answer, so we can do the same thing as we would with a calculator, where we say, I want this variable to be equal to the result of this calculation. With C#, we like to make sure that our coding statements are very easy to read, so it's a coding convention. It's not a rule, but it is a standard kind of a thing that people do to put a space before and after every operator. So you might like to condense your code and have 3 plus 4 without any spaces in between, but that would be violating the C# conventions. So I'll call you on it because we want to make sure that we're using the same conventions that have been developed over years of experience and are requested with C#. We might have different conventions in a different language. Now, the basic math operators that we can use are addition, subtraction, multiplication, division, and the modulus operator. This visual shows memory, and in memory we have some variables. We have a variable named first value, and it contains a value of 67 in memory there. We have another variable named second value that contains a value of 3, and then we have a variable named result. In this math equation here, we're going to set result equal to whatever the answer is of the equation 67 modulus 3. Well, the modulus operator gives us the remainder after a divide. So we would take operator 1 divided by operator 2, and the answer would be the remainder of that division. So here they show it in longhand using old division. We have a number 67. We're going to divide it by 3. Our first step, we say, 3 goes into 6 2 times. That accounts for 6 of those 6. Bring down the 7. And again, I say, 3 times 2 gives me 6, which goes into 7, and the resulting remainder from my divide operation is 1. Notice I'm not going to do decimal places here because I'm talking about integers. So a modulus is going to give me the remainder as an answer. Now a sign can also be important in this. If the sign of my dividend is negative, my result will be negative. If the sign of my dividend is positive, my result will be positive. We're used to a plus sign being a math operation. It can also indicate that we should concatenate multiple strings. So here we're saying that we want to take this full name variable and we want to update its value to be set equal to the first name variable, which is Rochelle, plus a space character, and that space is set up as a string within double quotes, plus the last name variable. So the result in full name would be Rochelle space Howard, concatenation. Here's a picture of that. Only they left the space out of there. A little space there. It's a little teeny space. We end up with this as the full name. Because addition and subtraction are such common operations, we can also use unary operators, which mean we're going to add 1 or subtract 1. That's why they're unary, 1 digit. So if I put a plus sign after this variable num, then at the end of the current line of code, num will be incremented by 1, or 1 will be added to it. Now, if I put the pluses before the variable name, then that incrementation would occur before the statement is executed at the beginning of the statement or line of code. We'll look at that. Now, in this case, I have a negative value. That's going to subtract 1 from the variable value 1. Now, they kind of mess that up, right? Because they put this 1 on here, but they didn't put the 1 over here. So it should be value, not value 1. Now, if we are doing a pre-increment, that means before the statement is executed. If it's a post-increment or decrement, we're going to do it after the statement is executed. And we can tell that by where the plus or the minus signs are placed in regards to our variable. So here we have a number 100. In this first line of code, we say we want to write a line that contains that variable and then increment that variable. So when the write line statement occurs, the variable will be equal to 100. It'll display 100. Then num will become 101 after it has been printed. If we did another write line at that point, we would see it's now 101. If we did a third line of code where we did a pre-increment and we put the plus signs before our variable name, then we would be adding 1 to that variable at the beginning of the execution of this line of code. So our output would display the updated variable. So really cool stuff. Gives us a lot of options here about how we can do things. When we're working with variables and we're going to be using them for certain functions, we want to make sure we name them appropriately, like a counter or the variable count to keep a count of things, a result variable to hold some sort of calculation, maybe, different things we can do. Back up to this one. That looks like a little wonkety, doesn't it? I think this integer should be named x. And we can start it with 100. And then we would print out the value 100. Then add to it. So it would become 101. We would print out a space. And then we would add more to our output. And what we want to add now is the pre-incremented value of x. So the 101 would become 102. I don't know where they came up with this variable named num, because that's not the variable that they used in their write line. All right, so we can try some different things. Here's some examples for you to try. Do some different things with Visual Studio, do some experimenting. Now we can use an accumulator type operation, a compound operation lets us do that. Sometimes we want to just add to a total, like this new number, or subtract from a total, or maybe we want to multiply a number by another number or divide, etc. We can use compound arithmetic operations to do that. So this plus equal says take whatever is on the left hand of the operator and add the value on the right side of the operator to it. So here we start out with a variable named answer. We give it an initial value of 100. Then we execute the line of code x answer plus equals 50 times this calculation. Now this calculation we have to do order of operations to decide how things are going to occur. First we're going to add or multiply 50 by 3, right? So that's going to give us 150. The resulting operation then, the resulting calculation will be 150 divided by 25 minus 4. So we would take 150 and divide by 25 as our next step, giving us 6. Then we would finally do the subtraction, and that would give us 2. So in the end, the statement answer plus equal this expression is going to give us a result of 102, because we'll be adding whatever this is to the variable answer. When we're looking at our different math operators, We have to be concerned, of course, about our operator precedence, but now we have to be concerned about where they are within these different operators that give us additional capability. So our unary operators, where we're just doing one thing, are going to be, right associative. Multiplicative would be left. That means that our multiplicative would happen first, and then additive and assignment statements, again, are going to be left and right, so we can see how those work. The best way to understand some of these are to do some practice problems in Visual Studio. So here's a few that you can try, and you can definitely try many, many more. Get all of those meme formulas that ask you what the right answer is and put those in and see how they work out and try to figure out what the order of operations was that made those work. Now here's some information that's really important to us. When we're working with different types of data, C# can automatically or implicitly change our data types for us, but sometimes it's not what we want, and sometimes we can't have that happen implicitly. So for example, it's really easy to change an integer into a double, right? You just add a decimal place with no decimal portion, and that changes that integer. But we can't really go from a double back to an integer, right? Because we would truncate all of that decimal place. So C# doesn't let us do an implicit conversion in that kind of change. We have to explicitly convert it ourselves. Now here's an example. In this case, we have a variable that's a double named answer, and we want to set answer equal to whatever value is returned by the calculation 10 divided by 3. We're surprised that it doesn't give us a decimal place. Why would that be? In this example, we have an integer named value 1, and we've set it to 440, and another integer, another number that's equal to 70. We're going to set up a value 2 that is 100.6. And then we update that double value with our integer value. No problem. We have 440.0 stored. Now in this previous example, what's our problem? We have two integers, so we did integer division here. Our answer is going to end up being 3 because we're going to lose that decimal place. If we try to convert things that cannot be implicitly converted, like a double into an integer, we'll get an error. So what can we do about that? We can cast this as another data type. When we use a cast, we're saying, I want to change it to this data type, or just pretend it's this data type. I don't care if there's the data lost or not. Now, when we do a casting, we do it by placing the data type we want to temporarily cast this number to within parentheses. So for example, in this example, we have value 2 that contains a decimal, value 1 that's an integer. We can cast that double as an integer, which will truncate that decimal place, and place it into value 1. Now, we couldn't do that without this casting because C# would say, no, I'm not going to lose your data, but you can lose your data. So you can say, I cast it, I force it to be changed, and that will happen. Now, in this case, we can go the other direction and say, I want my number to be cast as a double so that it carries a decimal place. So we could have done that with our division earlier, right here. If we cast either of these numbers as a double, then our answer would result in a double. So do try some of that. Now we'll stop our video here. We're done kind of talking about arithmetic expressions. Do a lot of experimenting. This will give you a lot of power if you have a good understanding of how the order of operations is working and how to format different mathematic functions. So thank you.